Okay, hi there. Today we're going to demonstrate using an ID fan on a pulverized coal plant. This plant has 4 fans. We're going to show what happens when you lose one of them. Right now we're running about 500 megawatts. This is gross. There's about 470 megawatts going down the line. This plant requires about 30 megawatts to run the fans, pumps, and coal equipment. Boiler pressure is 2,400 psi right now. This is where you run the plant from, basically. You can type your destination in and change your megawatt level here. Here's your turbine master, and your boiler master is on the other side. You can take manual control and run the plant manual if you have to. Right now it's a boiler follower with megawatt loop. This means the boiler is following your turbine. It's maintaining 2,400 pounds pressure. Your turbine's trying to hold the megawatts. Down here's your megawatt. Throttle pressure is 2,400. Furnace pressure is -0.5. Get your drum level. Reheat's running about 985. Reheat's 975. Okay, we got an alarm. Okay, we got ID fan B, running 384 amps. We'll go to the screen. This is the ID fan screen. Okay, it's pulling a lot of current. Looks like the stator temperature's coming up. We're going to make an announcement to keep everybody away from the boiler in case the fan trips off. Attention all plant personnel. Avoid the boiler area. We're having problems with ID fan. Stay clear of the boiler. Having problems with ID fan. If we do lose it, it'd be bad. It could go positive, and if you're rotting bottom ash, which nobody is, or you're looking in the boiler doing an inspection, you could get fire back at you. Okay, I'm going to try to bias it down. This should shift the load to the other 3 fans. Maybe it'll bring down the current. Put in a negative bias, maybe 10%. The other fans are picking up. We're still coming up on amps. Temperature's still pretty high. Right now we should probably trip this thing. Okay, it just tripped on its own. That's a trip. Go to the alarm screen real quick. These alarms, furnace pressure just went high, got 1.2, went positive. So this is why you would not want to be looking into the furnace when you lose a fan. We're going to go to the primary air fans. These are the fans that use air to blow the coal out of the pulverizer to the boiler. Now we've just gone negative. The trip down here is -8, so we're okay. It's caught it. Forced draft fan control. These are the fans that are pushing air into the boiler to complete combustion. Still a little bit negative. I'm going to go to the boiler feed pump, just take a quick look at them. These are the 2 boiler feed pumps. This one's pumping about 3,300 gallons a minute, 2,768 pounds per square inch. So these are feeding the boiler. These runs off a speed. There's no control valves on these. So if you need more water, the boiler, the pump speed kicks up, or if you need less water, they slow down. Anything over 300 megawatts requires 2 pumps. Furnace pressure is still a little bit off. Everything else looks pretty good on it. You see the temperature is still pretty hot on it. Your average drive amps, this is the average, takes a little bit for this to come down. I'll make sure both dampers have closed. Kind of saw that when it first went down. Otherwise, your flue gas will recirculate. It'll go here, then it gets sucked back around, then you'll have a real problem with your draft. Okay, at this point, we're going to see when we can restart this thing. Okay, we had an operator check out the fan and the equipment. Looks like somebody accidentally hit the trip on the breaker. So we're going to go ahead and restart the fan. First thing we need to call out and let everybody know to stay clear of the area. Attention all plant personnel, starting B, ID fan, starting B, Bravo, ID fan, please stay clear of the boiler. Good idea to let people know you're starting equipment. We also have an operator stationed out there. Okay, to start the fan, you have to go to normal select, minimum select. Minimum select is like turning gear. It'll start at about 72 RPM. Got pretty high current coming in, about 800 amps. This would be the current going out to the motor to get it to roll. So these are pretty heavy duty VFDs to control this kind of a motor. This plant runs the draft just on the speed of the ID fans. The dampers are full open when you're running. Okay, here's the ID fan screen, runs 72 RPM, not pulling a lot of current, stator temperature's down. Looks like we had a good start. Temperatures are good. The oil pump's running. Vibration, temperatures look good. You usually want to roll these out for like 4 hours when you first start them, just in case there's any bowing in the shaft. Okay, we're going to go to normal select. This allows us to run the fan speed up. A alpha fan is running 454 RPM, so we're going to try and match that. I'll just have to highlight the boxes. As we bring up the fan speed, the current should come up. And it's coming up, and the current's coming up with it. There's not a load on the motor because the inlet damper is still closed. As this speed comes up, the other one should be staying pretty closed. Should be staying where they were. We went to normal select, the outlet damper opened, the inlet damper is still closed. Yeah, we're almost there. See, the current's picked up some since we brought up the speed on it. Once we get the speeds matched, we'll put it in auto. Okay. It's in auto. So it should be running about the same speed as the others. Now the big thing with this, when you put this in service, when you start opening the inlet damper, it could pick up any dust in the ducts, and it's going to give you an opacity exceedance. You could get high opacity. So we're going to start by opening it really slow. And when we do this, we'll have to watch the opacity. That's up here. This is the precipitator. This is where all the dust is knocked out, the flue gas. These are the air preheaters. You have your dampers go in the air preheaters where you can change the flue gas to and amounts to different air preheaters to heat the air coming out. These are feeding the pulverizers. So this is used to dry the coal while it's being ground and blown in the boiler. And these are reclaiming heat from the flue gas and putting it back into the boiler. So you can see the opacity is starting to come up a little bit. Up here is opening up the damper. Starting to come up pretty good. We probably won't go much more. Unlike a lot of valves and dampers, a lot of your control changes within about the first 20% or so. We're at 2.2. Comes up much more, we'll have to quit. 2.7. I'll have to watch it here and see what it's going to do. The inlet damper is 19% open, so it's pulling some gas. I mean, the amps are down. It should be around about 131 amps like the other ones. So we're at 3.2 now. It seems to still be coming up. We'll go look at the precipitator and see what that's doing. This is an electrostatic precipitator. These cells are out of service. They can't get the ash out. They rocked up from water, moisture getting in there. But as long as you don't have several of these out in a row, you're okay. Here's one of the precipitators. You have your sparks per minute to right now the secondary voltage about 64,000 volts. Firing angle 89, that determines how hard they're firing. So there's around 50,000 volts or so usually on the plates in here to knock out the particulate. Then there's wrappers that knock out the dust. These are the wrappers that are running right now. Their rods I'll drop and hit the plates and knock the fly ash down to a hopper, and then that's sent out the NUVA feeder using air to transport the fly ash out to the fly ash silo. Go back to the ID fan. Looks like the opacity's coming back down. So we probably got the dust out. I'll have to watch the furnace pressure now down here. We don't want this to go too far negative as we open it up. It's going to take a little bit to catch it. See, the opacity's still doing good. It's 1.2 coming down. Amps are picking up. Furnace pressure's driving down a little bit. Like I said, most of your changes in your first few percent of the movement of this right now, we're just going to make a slight change to it. Amps are coming up pretty good. First pressure went down to a negative inch. So we can just drive it the rest of the way open. And ID fan is back. We have all 4 ID fans. And that was losing one ID fan. Losing 2 of them is a different story. It would be a lot different outcome in the plant. But the big thing, you have to be careful around these boilers. If you lose a fan or something happens where you're looking in, it will blow the hot gases back at you. Especially rotting bottom ash on these. You have a door open, exposed to the firebox, running a long rod on a jackhammer trying to break up the large clankers or pieces of ash that have fallen down. So you can rake it out. It goes down to a cinder grinder, then you grind it up and send it out with the water sluice setup. But that's losing an ID fan, and plant's back running.